this lesson, we're going to be talking about the laws of exponents. Now, the laws of exponents are basically rules that you're going to apply to expressions that have exponents. And all of these laws of exponents have names, as you can see in our little table here, and you don't need to necessarily memorize these names, but you are going to want to know how to take these laws and these properties and apply them to various expressions. So before we get started looking at each of these individually, let's look at some vocabulary. Let's look at the word monomial. A monomial is a real number, a variable, or a product of a real number and one or more variables with a whole number exponent. So some examples would be what I have here below. Obviously, you can see that I have the number 7. And a number 7 is just a real number. So that is going to be part of our definition of a monomial. You can also see that I have a variable x, and then I have a coefficient with the variable x. And then I have two variables put together. These are all types of monomials. And then it gets a little bit more complex. You can see in this next one that I have multiple variables with a coefficient, and then some of those variables have exponents of 1, and then others have exponents that are whole numbers like 3 and 2. Same thing with the next one. And then you can see that I have a situation where I have parentheses with an exponent outside. And you'll also notice that exponent is positive. And then in the last scenario, I have parentheses with another exponent, but now the exponent's negative. You might be thinking, well, the definition says that the exponents must be whole number exponents. Well, we know that a whole number isn't a negative number, so I'm going to teach you how to make that negative number positive when we go through this lesson today. So let's go ahead and take a look at each one of these laws of exponents individually. Okay. The first rule, or the first law of exponents, is the product of powers rule. So as you read through textbooks, as you go on in your math career, you're going to be seeing examples that look something like this, where everything is going to be letters and operations. So here I have x to the m power times x to the n power equals x to the m plus n. What this is saying is when you have two bases that are the same, and you can see that my base in this is going to be x, and you can see that those are identical, and you're multiplying. See that I have a multiplication sign? What you're going to do is you're going to take those exponents and you're going to add them. So a really, really easy example would be something like this. If I have x to the 4th power times x to the 2nd power, you can see that in this example, my bases are the same, they're x, and I'm multiplying. So what I'm going to do is I'm going to add those exponents to give me x to the 6th power. That's called the product of powers rule. So let's go ahead and apply this rule to these problems below. And let's just take a look at the first one here. I kind of bumped it up a little bit, so you can see that I'm actually going to be multiplying 3 different monomials, or 3 different terms. So if I look at this one, the first place where I want to start is I want to start with my coefficient. You can see that I have a -3 in my first term, a 2 in my second term, and a 4 in my third term. What I want to do is begin by multiplying those coefficients. So I have -3 times 2, that's going to give me -6. And then -6 times 4 is going to give me -24. So that's going to be my coefficient when I multiply those terms. Now let's get to the exponents. Now I have a base of a. So you can see that a is the same all the way across. You can also see that obviously I'm multiplying within this expression. So what I want to do is add those exponents of a. You can see that I have a 3. I have a 4, and then I have nothing over here. A nothing does not equal 0. A nothing actually equals 1. So that's kind of hard to remember sometimes, but you have to kind of remember that. I'm going to show you a little bit later a 0 rule, which might help you out. So if I add these, 3 plus 4 is 7, plus 1 is going to give me 8. So this is going to be -24a to the 8th power. And that is going to be my simplified form using my laws of exponents. Okay, let's try another one. In the next one, I'm always going to start with my coefficients. -4 times -4 is going to give me +16. This time, I have 2 variables that I'm working with. I'm working with x and working with y. I'm going to start by just working with the x. So you can see that I have a base of x. If it helps you, you can actually just kind of take the x's out of the whole expression and say x to the third times x, and that might help you simplify these two monomials. So x to the third times x is actually going to be x to the third times x to the 1, right? So that's going to be x to the fourth. So I'm going to write x to the fourth next to my 16. Now I'm going to work on my y's. You can take them out of the problem if you'd like, and what I'm doing is just I'm kind of rewriting them above. You don't have to do that, but if that helps you distinguish between the variables, you can do that. So y to the third times y to the fourth, you can see that I have like bases, and I'm going to add those exponents because I'm multiplying. So I'm going to have y to the seventh. Once you've taken care of the coefficients and each individual variable, you're finished. So my final answer for this one is 16x to the fourth, y to the seventh. Let's take a look at one more using the power rule. I'm sorry, the product of power rules. All right, I'm going to start with my coefficients. My coefficients are 4, and don't forget about the invisible -1. So my coefficient is going to be -4. Now I'm going to work with my h's. I have h to the first power times h to the fourth power. I'm going to add those to give me h to the fifth power. Now I'm going to move to my k's. See how I have a, oh, I'm sorry, let's go to the j. I have j to the first, and then over here I have j to the second. So 1 plus 2 is going to give me j to the third power. And then my last variable, you can notice that they're out of order, and that's perfectly fine. I have k to the second power times k to the first power. So that's going to give me k to the third power. And it doesn't matter what order they are in. If you'd like to put them in alphabetical order, that's perfectly fine. But this is definitely going to be a finished product here. All right, the next law of exponents, very similar to the product of power rules, but now we're going to be working with division. This is called the quotient of power rules. You can see that I have a division symbol, and I have x to the m divided by x to the n is going to equal x to the m minus n. So very similarly to the one above, the only difference is we're going to be subtracting the exponents. So when two bases are the same, you're dividing. When two bases are the same and you're dividing, you want to subtract those exponents. So let's go ahead and look at the first one to see what we're going to do here. Notice how my base is, I have an n and an n. That's my base. So I know that my base answer is going to be n. Now, I'm going to take my exponents, and I'm literally going to say 3 minus 2. We know that 3 minus 2 is 1. So really, it's going to be n to the first power. But we don't need to write n to the first power like this. We can write n to the first power as n. Okay, let's bump it up just a little bit. Okay, so in this one, we first have a coefficient. And first one, we didn't really have a coefficient there other than 1. So let's work with our coefficients. Personally, I like to start mine by drawing a little division symbol. And I'm going to say 4 divided by 2. 4 divided by 2 is 2. And I'm going to put my answer in the numerator. When in doubt, always put your answer in the numerator. Okay, let's work with my m's now. Notice how I have m's, but they're all scattered about. If you want to, you can use that same little tool we did above, and you can say m to the 6 over m squared. You can kind of pull it out of the fraction and do it that way. But I have like bases, and I'm dividing, so I'm going to subtract my exponents. So I'm going to have m to the fourth power, and I'm going to put that on the top. And the reason that we're going to be putting on the top is this. If you look at the situation here, I'm going to have 1, 2, 3, 4, 5, 6 m's in the numerator. And then I have 1, 2 in the denominator. And we know that like terms we can cancel out. And you'll see that I'm left with 4 m's in the numerator, which is why I placed it in the numerator. As we get more complex with these problems, you're going to get better and better at knowing where to put your exponents. Okay, now let's look at my n's. I have n to the fourth and n to the first. So I'm going to say 4 minus 1, and that's going to leave me with n to the third power. Now, obviously, this is all going to be over 1, but I don't need to write it like this. Let me erase my m's down here so I can rewrite it properly. Okay, this one, I'm just going to rewrite it anything over 1 is going to be itself. So I'm going to write it 2m to the 4th n cubed. Okay, let's try the next one. A little bit more complex now. All right, let's go ahead and try this one. I usually like to start with putting a fraction bar there just to divide my top and bottom. I'm going to start with my coefficients, saying 6 divided by -3. That's going to give me -2, and I'm going to place that on the top. Then I'm going to work with my a's. You can see that I have a to the 7th, a to the 3rd. I'm going to subtract those exponents. A to the 7th minus a to the 3rd. And feel free to, you can circle it or you can even pull it out of the fraction if you'd like to. So that's going to leave me with a to the 4th power. Now let's work with my b's. I have b to the 8th divided by b to the 4th. If I subtract those exponents, that's going to leave me with b to the 4th power as well. And then, of course, I'm going to work with my c's. And 5 minus 2 is going to give me c to the 3rd power. Again, I don't need that fraction bar, so I'm just going to rewrite my answer as -2, a to the 4th power, b to the 4th power, c to the 3rd power. Okay, now that's the quotient rule. Let's keep going and learn a couple more rules here. All right, they're going to start getting a little bit more complex as we go on in this unit. So the power of power rule. So the power of power rule is basically when you have a power and you're raising it to another power. So you can see here that I have m to the n power. You can see that right there. When that happens, you're actually just going to multiply them together. So let's look at this first example here. I have b to the 8th to the 5th power. If I multiply those two powers together, that's going to leave me with b to the 40th power. Now, the second example gets a little bit more complicated. So I have not only a coefficient in the front, but the coefficient happens to be negative. We know that whenever you take a negative number and you raise it to a power, it's actually going to look something like this, -3 squared, which we know is -3 times -3, which is going to leave you with 9. So here, I'm actually going to raise that -3 to the 2nd power, and that's going to be 9. But now I have a variable to take care of. I have b to the 3rd, and I'm squaring it. So since I have 3 and I'm squaring it, I'm going to multiply those exponents to give me b to the 6th power. So my answer is 9b to the 6th power. Okay, let's try another one. I threw another negative in there just for fun. So you can see that I have an invisible -1 here, and I'm going to take that -1 and I'm going to square it. Taking -1 and squaring it is the same thing as saying -1 times -1, which is going to equal 1. So really, it's just going to be 1 as my coefficient. All right, now you can see that I have m to the 7th, and he's not right next to the parenthesis, but we are squaring him. So we're really taking 7 and we're going to multiply it by the 2. So we're going to have m to the 14th power. Then I'm going to take my p, and I'm also going to use the power of power rule, and I'm going to multiply it by 2. So that's going to leave me with p to the 8th. And then, of course, I have my q to the 9th, which I'm going to raise to the 2nd power, and I'm going to multiply them. So I'm going to get q to the 18th power. And we know that we don't need to necessarily write that coefficient of 1, so I'm going to rewrite my answer as m to the 14th, p to the 8th, q to the 18th. And that is my simplified monomial. Okay, now let's apply the power of a quotient rule. So a power of a quotient rule works very similarly to the power of the power rule, but now we actually have some division. We have a quotient. So let's take a look at this rule. It says x over y is in parentheses, and it's raised to the m power. So basically what happens is not only does the x get raised to the m power, but the y gets raised to the m power as well, leaving me with x to the m over y to the m. So with a numerical example, this is what this looks like. So in the first example, I have x to the 5th raised to the 3rd. So I'm going to go ahead, and you can see here that I still have the power of power rule. So I'm raising it to that power. So I have x to the 15th power. Now the new part is going to be the bottom. The bottom, it really technically looks like this, g squared to the third power. I'm raising him to the third power as well. So that's going to leave me with g to the sixth power. So it's a little combination actually of the power rule, but you're working with quotients this time. So it applies to the numerator and denominator. Okay, let's try another one. I threw a coefficient in there this time. So now I have, let's just focus on the numerator. So my numerator is going to be 2 raised to the second power. Well, 2 squared, that's going to leave us with 4. Then I'm going to have p squared squared. So I'm going to use my power of power rule in this case and say p to the fourth. But since I have a denominator, I'm going to use that power of a quotient rule. M also has to be raised to the second power. So I'm going to say m to the second power in the denominator. And now I'm finished. Okay, one more. I bumped it up even a little bit more. I'm going to start in my numerator, and I'm going to say 3 raised to the second power. Well, 3 squared is going to be 9. And then x squared squared. I'm going to use that power rule, and I'm going to say z to the fourth power. Now, applying that power of a quotient rule, I'm going to do the same thing to the denominator. So I'm going to say y. Now, this is y to the first power. So I'm going to say 1 to the second power is 1 times 2. So that's going to be me y squared. I treat each one of these variables independently. X to the seventh power is really going to be x squared, which is x to the 14th power. And you're finished. All right, we've got a couple more to look at. Okay, now we're going to start getting into negative exponents, and this is where things get a little bit more complicated. Now, the rules up above might look a little complex, but let me kind of explain it to you. So basically what the negative exponent rule is saying that is if a variable has a negative power, the variable moves across the fraction bar and becomes positive. So if it's in the top, meaning it's in the numerator and has a negative exponent, you're going to move it to the bottom and make it positive. Now, if it starts in the denominator and it's negative, you're going to move it to the top and make it positive. And that's what this rule is stating right here. Now, another part of this negative exponent rule is when you have fractions. So notice that in this first fraction I have x over y, and it's raised to the negative n power. So what happens is, if you have a negative exponent, you don't want to raise everything to the negative exponent. That makes things fractions and makes things a little bit more complicated. So all I want to do is I want to take what's inside that xy and I want to flip it over. You'll see when I flip it over, I get y over x. And what I did there is I changed my exponent to positive. So I'm basically taking its inverse. All right, let me show you what this looks like. So I have 6 examples here because it's kind of complex. So I have 3x to the negative 2, okay? So 3x to the negative 2. The first thing to know is that there is a numerator and there is a denominator. And personally, I like to look at this like this. I like to look at it as the expression given to me is over 1. So what I'm going to do is I see that 3 is a coefficient and 3 stays in the numerator. So I'm going to leave 3 in the numerator because 3 divided by 1 is positive 3. Now I'm going to look at my exponent and my variable, x to the negative 2. Since I'm in the numerator, what I'm going to do is I'm going to bump him to the denominator and make my exponent positive. Now I have a simplified expression. All right, let's keep getting a little bit more complex here. This time I have a numerator and a denominator. So personally, I like to draw a little line here, and I like to start with my coefficients. My coefficients are 1 over 2. Well, 1/2 does not simplify, so I'm going to write 1 over 2. And what I mean by not simplify is it's not like 2 over 4, which simplifies to 1/2. So 1/2 is already a simplified fraction. So I'm going to leave him as is. Now I'm going to look at my x. X to the negative 2. Notice that he's in the numerator and he's negative. I have to move him to the denominator and make him positive. Now I have y. Y to the negative 5 is in the denominator, so I'm going to move him to the numerator and I'm going to make him positive. And that's your final answer. You technically don't need this 1 right here because obviously it's a coefficient of 1 and you don't need it, but feel free to write it if you'd like. All right, more complex problems. I have a numerator and denominator, so I'm going to go ahead and write that line. And let's look at my coefficients. I have a 3 and I have a 1. 3 divided by 1 is 3, so I'm going to rewrite a 3 in the numerator. Now I have various variables to work with. I'm going to start with my x. Notice how my x is to the first power. He's positive. I'm going to leave that x right there in the numerator. I'm going to continue working in my numerator here. W to the -4. Obviously, -4 is negative, so I'm going to move him to the denominator and make him positive. My last variable in the numerator is c. C to the first power. That's positive. I'm going to leave him in the numerator. Now let's bump down to the denominator. Y to the -10. Y to the -10 is negative, so I'm going to bump him up to the numerator and make him positive. M squared, well, the 2 is positive, so I'm going to leave him right where he is in the denominator. And I'm finished. Okay, now let's work with the second half of that rule. So this part over here, this is what we're going to be working on in the second row here. All right, the first thing I have here, you can see is that I have a negative exponent. I never, ever, ever want to raise something to a negative exponent. I have to actually transfer it first. So what I'm going to do is this. I'm going to rewrite it like this, parentheses, and I'm going to change my exponent to 5. And what I'm going to do with the inside is just flip it over. I'm going to say that CD is in the numerator, and I'm going to say that AB is in the denominator. Now what I can do is I can simply use my power rule or my quotient of power rules and simplify this down. So this would be C to the 5th power, D to the 5th power, A to the 5th power, and B to the 5th power. And I'd be done. Okay, I have another one just like it. I have a negative exponent, so what I'm going to do is I'm going to first start by making him positive. I'm going to flip everything that's inside. Now, a common mistake that I see is that whenever we flip inside, we also, that y at the bottom, we make it positive. That's not what we're doing here. We're going to take it exactly like it is, and we're going to write it exactly how it is. All we're going to change is that exponent outside. Now, we're going to finish the answer. Let's use our quotient of power rules. Y to the -4th squared. Now, this is a power to power rule. -4 times 8 is going to give me y to the -8. In my denominator, I'm going to raise that 3 to the 2nd power. 3 times 2 is 6. So I'm going to have x to the 6th power. Now you can see here that this is not satisfied. We have to make that negative exponent in the numerator happy. We have to make him positive. So what I'm going to do is I'm going to move him to the denominator. So I already have an x to the 6th down there. I'm going to move my y to the 8th down there as well. Now, once you move that y, what's left over? Well, just a 1. And you're finished. Okay, the last example I want to show you here is kind of a unique one. You can see that my exponent outside in the denominator is negative. So watch what I'm going to do here. This is actually kind of cool. I'm going to take that whole thing in the bottom, and I'm actually going to bring it up to the top. So I have an m up to the top. I'm also going to do this. I'm going to say w to the 4th, and I'm going to change that power there to a +3. I move the whole thing up to the top. You could have also used the power rule and multiply these two to give you a negative number and then move the w, but it doesn't really matter. Okay, now let's simplify. M times, I have w 4 to the 3rd. That's going to give me w to the 12th over 1. And of course, we know that that simplifies to mw to the 12th. All right, we are moving right along with our exponents. Now I have some more exponents for you that these two rules are pretty easy. The identity exponent rule. What the identity exponent rule is this. We have x to the 1st power is equal to x. Basically saying when a variable is raised to the power of 1, it equals itself. So if I said y to the 1st power, that's just going to be y. A to the 1st power, that's just going to equal A. And then I love this next property, or this next rule, the 0 exponent rule. Anything raised to the 0 power is going to be 1. So if I have y to the 0 power, that's going to be equal to 1. If I have parentheses A, B, C, D, and I raise it to a 0 power, that whole monomial just changes into a 1. Kind of a cool property. Okay, now that we know all of the laws of exponents, let's go through some more challenging examples. So you might feel free to, you might like feel comfortable about this, so you can pause the video or stop the video, but I am going to do examples. I'm sorry that this video is kind of long, but it gives some really good examples on how to do these. So feel free to pause or cancel out at this point. Okay, apply the laws of exponents to the given monomials. So here I have 3 monomials and I'm multiplying them. So I'm going to apply all these exponents to them. Exponent laws to them. All right, let's start with my coefficients. I have a 1, a 4, and a 4. So my coefficient is going to be 16. Now I'm going to work with my x's. Notice that I have -4 and I have -3. And so I'm going to go ahead, and since I'm multiplying these, I'm going to add those together. So that's going to give me x to the -7. Now you might want to move that to the bottom right now, but let's just pause and get to the very end here, and then we'll move it around. Now let's work with our y's. We have -2, we have 0, and we have 1. So I'm going to say -2 plus 0 is -2, and -2 plus 1 is -1. So y to the -1. At this point, we're finished, except for our negative exponents. Now remember, everything can always be put over 1. So really, we do have a numerator and a denominator here. So I'm going to say 16. And I'm going to bump my x to the 7th and y to the 1st power down to the bottom. And that will be my final answer. Okay, in the next one, we have a power-to-power rule. So I'm going to take my 2 and square it, and that's going to leave me with 4. And x to the 2nd power, which is going to leave me with x squared. And then y to the -7 times 2 is going to leave me with y to the -14. Now, this is a monomial, and I'm going to multiply it by the other monomial. Let's use my product rule. 4 times 2 is going to leave me with 8. X squared times x is going to leave me with x cubed. Y to the -14 plus 8 is going to leave me with y to the -6. Obviously, we're not done here, so I'm going to go ahead and move him to the denominator. 8x cubed is going to stay in the numerator, and then I'm going to bump y to the -6 into the denominator. I'm sorry, +6 in the denominator. Whoops. There's your answer. Okay, now I have some rules to apply before. So let's just work with my numerator right now. 2 times 2 is going to leave me with 4. X times x to the -4 is going to leave me with, this is a 1, and so I'm adding them, so x to the -3. In my denominator, you see that I have 4x to the 3rd. Now let's apply the quotient rule. 4 divided by 4 is 1, so I'm not going to write any coefficients. But then I have -3 minus 3. So that's going to leave me with x to the -6. I can't leave him there, so I'm going to flip it around and say x to the 6 is on the bottom with a 1 on top. Okay. These are the last examples I have for you today. And let's take a look at the first one. Let's multiply straight across. My coefficients are 2 times -5, which is going to be -10. My x's, I have a -3 and I have a -3. So I'm going to add them to give me x to the -6. My y's are going to be 2 and 1. So it's going to give me y to the 3rd power. Z to the 0 power here is just 1, but I could also add them together. So 0 plus -2 is going to be z to the -2. Now that I've taken them all across, let's go ahead and put them in the numerators and denominators. -10, remember that -10 is a coefficient. He is not a negative exponent, so I'm going to leave him in the numerator. X to the 6 comes to the bottom, y to the 3rd stays on the top, and z to the -2 comes to the bottom. Okay, the next one, let's go ahead. I'm going to draw my division symbol. U squared to the 4th is going to give me with u to the 8th. V to the 7th raised to the 4 is going to give me v to the 28th. 2 to the 4th, well, 2 to the 4th is going to give me 16. 8 to the 4th, that's going to give me 32, so u to the 32. And then v to the 9th to the 4th is going to give me v to the 36. Notice how I have big numbers here, but that's okay. You can still apply the laws of exponents. All right, my coefficients is going to be 1/16. My u's, let's look at my u's here. This is how I like to do it. I like to look at it and say, okay, let's do the quotient rule. 8 minus 32. That's going to leave me with u to the negative 24th. I'm going to put him in the top. Always put him in the top. I'll move him to the bottom in a moment. Now let's look at my v's. 28 minus 36. That's going to be v to the negative 8th. Now I'm going to take it one extra step and I'm going to move those negatives. So now I have 1/16. I'm going to move my u down and I'm going to move my v down. All right, I love this next one. Remember, when I have that negative exponent, what I can actually do is take it right up to the top. So I'm going to start here. I'm going to start with b to the 8th, and I'm going to bump that whole thing up to the top. So a to the 5th, b to the 4th, and I'm going to change that exponent to positive. So this is all over 1. Now I'm going to go ahead and apply my rules. So I'm first going to go ahead and do my power to power rule, and then I'm going to do my product to power rules. So I'm going to do this portion first. So what I have here is b to the 8th, and then I have a to the 30th, b to the 24th, all over 1. Now let's go ahead and apply the product rule. All I have to add here are the b's. So I have a to the 30th, and I have b to the 32 over 1, which of course we can simplify just to a to the 30th, b to the 32nd. Okay, and our last one here. I love this one. This is so cool. See this whole numerator? He's raised to the 0 power. So this whole thing just becomes a 1. So now what we're left with is 1 over 2x to the negative 2, y to the 7th, z to the 9th. Now let's go ahead and manipulate this. My coefficients are 1 over 2. My x is negative, so I'm going to move him to the numerator. My y and z are positive, so I'm going to leave them in the denominator. And I am finished. Okay, so hopefully that was a good review and a good look at the laws of exponents. Feel free to go back and take a look at these individually at your leisure.